All right, so I want to remind you how to solve equations. It's going to be very important to what we do today. I want to remind you how to solve equations. What I teach my students is to label constants and variables. Anything with an x in it, we call it a variable. Anything without an x in it, we call it a constant. And I ask my students to get all of the variables on one side of the equal sign and get all of the constants on one side, all the variables on the other side. Sometimes for students who have some challenges in this, I ask them to label the X as a boy or label the C's girl. So you got boy, girl, girl. Get all the boys on one side of the equal sign. Get all the girls on the other side of the equal sign. Hopefully you see that this constant, or this girl, however you want to look at it, needs to be moved on the right side. Now, how do you move this minus 3? Well, you have to add 3 on both sides of the equal sign. You end up with 2x is equal to the sum of those two numbers, which is 7. Now, to isolate the x or solve for x, you do the inverse operation of multiplication, which is divide. On both sides, you get your answer is 7/2, or 3.5. Rushing a little bit. Sorry about that. 7/2 or 3/2. For what we do today, it's very important that you know how to solve equations. Let's look at one more. Again, let's label constants and variables. That's a constant, variable, constant, or girl, boy, girl, however you want to look at it. Who has to move here? If you want all the constants on one side of the equal sign, you want all the variables on the other side of the equal sign. If that's a girl, that's a boy, and that's a girl, you want all the boys on one side of this equal sign, all the girls on the other side. Who has to move? Hopefully you see that this 3 would have to move over there. It's a positive 3. So how do you move a positive 3? You subtract 3. How did you move a minus 3 over here? You added 3. You move that minus 3 by adding 3. How did you move this positive 3? By subtracting 3. Inverse operation. That cancels. This is a negative 2x, which is brought down. You get 5 minus 3, which is 2. Now you want to isolate the x. The inverse operation of multiplication is division. Divide by whatever's next to the variable you're trying to solve for. You get x is a negative 1. So we had to go through how do you solve a basic linear equation. How do you solve a basic linear equation? Before we talk about today's topic. So again, what did we do? We labeled constants, variables. All right? And then what we did was we moved according to, we tried to get all the variables on one side and all the constants on the other side. That's all this is about. Let's take a look at the problem. All right, so now this is saying solve for y. Solve for y. Anything with y in it, let's call that a variable. Solve for y. Anything with y in it, we call it a variable. Here, in this problem we just concluded with, we were solving for x. We were solving for x. Anything with x in it, we called it a variable. We were solving for x. That has x in it, we called it a variable. Here, we're solving for y. So, that 7x is, let's call that a constant. Solving for y, let's call that a variable. This does not have y in it, let's call it a constant. I want to say this real quickly. As we get more and more comfortable with this, we don't have to go through this labeling process because you'll be comfortable with it. But in the meantime, I just as soon introduce this technique of labeling everything before we begin moving these variables. All right, so we want to move the constants on one side and the variables on the other side of this equal sign. Hopefully you see that this 7, positive 7, has to move. How do you move it? You subtract 7x. Subtract 7x. So you end up with y is equal to negative 7x plus 12. And it's just that simple. You solve for y. And that's it. Now, there's going to come a time today, later today, we're going to do something with that, which is graph that on a coordinate axis. But for now, the directions say solve for y, so that's all we're going to do. Let's move on to the next one. Solve for y here. Solve for y here. Well, anything with y in it, we're going to call it a variable. That does not have y in it. Let's call it a constant. This has y in it. Let's call it a variable. This does not have y in it. Let's call it a constant. Let's solve for y by moving all of the constants on one side of this equal sign, and we're going to move all the variables on the other side of this equal sign. Hopefully you see that the 3x has to move. It's a positive 3x, so you move a positive 3x by subtracting 3x on both sides. This negative here is with the 4. All right, so you end up with that canceling. You bring down the negative 4y. That's a common mistake. Sometimes people want to bring down just the 4, but that is a negative 4y. Is equal to negative 3x plus 24. All right, so let's get the y all by itself. The way you're going to isolate this y is to use the inverse operation of multiplication, which is division. Divide by negative 4 on both sides. And what you end up with is you end up with y is equal to a negative divided by a negative is a positive 3/4 x. And you got to distribute that negative 4. A positive divided by a negative is negative 6. You've just solved for y. You just solved for y. All right, let's do one more problem where we solve for y. Again, later today, what we're going to do is we're going to graph that on the coordinate axis. We're going to graph that. But for now, we're just following the directions, which just say solve for y. Let's move on. Let's do one more. Let's label all the constants and the variables. 4x, we're solving for y. So anything with y in it, we're going to call it a variable. 4x does not have y in it. Let's call it a constant. Let's call 8y a variable. Let's call 16 a constant. You're going to move this 4x over to the other side. Negative 4x, subtract 4x. You end up with 8y is equal to a negative 4x plus 16. You're going to isolate the y by dividing by 8 on both sides, and you end up with y is equal to 4 divided by 8. Some students might think that that's 2, but that's actually 4 over 8, which is negative half x plus 16 over 8, which is 2. Final answer. Here, you just solve for y. I want you to notice that we could have said here 24 minus 3x. 24 minus 3x. But I chose to say negative 3x plus 24. Here we could have said 16 minus 4x. But I chose negative 4x plus 16. The reason why I did that is because I am trying to obtain a certain form. It's called slope-intercept form. Maybe you've heard it. Maybe you've heard it. It's called y. Let's call y equals mx plus b form. That's why I didn't say 12 minus 7x. I wanted x, mx plus b. I wanted negative 7x plus 12. All right. Now, the reason why I wanted this form is to graph it easily, because this is what you're going to have to do sometimes. You're going to have to graph these equations. All right? So let's show you how to graph. Let's show you how to graph this equation. Y, actually we're graphing, the original equation was 3x minus 4y is equal to 24. And the thing we're going to do is we're going to show you how to graph using mastery level techniques. We want to show you and teach you how to do the same problem in more than one way. So I call that mastery level understanding. I ask my students, and sometimes I even demand that they dominate problems. The name of this show is called Chicago Students Dominate. So I call dominating, not only are you getting the right answer, you're getting the right answer in 2, 3, 4, 5, sometimes 6 different ways. We only have time to show you 2 ways now. Let's dominate the problem, mastery level understanding. All right, the first method of graphing is to put this equation in slope-intercept form. Put this equation in slope-intercept form, and we've already done that. So I'm not going to do it again. So we got y is 3/4 x minus 6. 3/4 x minus 6. Now the first thing I'd like you to do, I've got my coordinate plane already drawn here. It's already drawn. So I'd like you to go to the y-intercept. In this case, it's a -6. So you go down to your coordinate axis, you go down to -6 on the y-axis. You do not go to -6 over here. Your first point is coming from this b. Y is equal to mx plus b. Your first point you're going to plot is to go to the last number in your equation, which is a -6, and plot it right here on the y-axis. Now what you're going to do is you are going to plot the second point using what we call the slope. Slope, by definition, slope for this problem, let's write it down here. Slope for this problem is, slope by definition means rise over run. Our slope is 3/4. Our slope is 3/4. So you're going to rise 3 and run 4 from this point. You're going to rise and run. You're going to use the slope to plot the second point, starting from this first point, which came from the -6. All right, so from here, and you'll also have to remember that that's a positive slope, up, traveling left to right, rising, and this is a negative slope. You're traveling down from left to right. So from here, you're going to rise 1, 2, 3, and it's a positive slope. It was a positive slope. You rose from here. You went 1, 2, 3, and you ran over 1, 2, 3, 4. You rose from here 1, 2, 3, and you ran over 1, 2, 3, 4. All right, and then you would draw the line like so. Draw the line, and that is how you graph the equation of a line. Well, you can't see that, I'm sorry. We rose 1, 2, 3, and we ran over 1, 2, 3, 4. All right, so that's the first method of graphing the equation of a line. The second method of graphing an equation of a line is to use intercepts. All right, so same problem, 3, okay, this is called the slope-intercept approach. Slope-intercept. The second approach to sketching 3x minus 4y is 24. The second way of graphing this line is to use intercepts, the x and y intercepts. All right, so the way you do that, the way you find an x-intercept, is you just make y equal to 0. We don't have time to talk about y today, but you just have to trust me. If you want an x-intercept, you have to make y 0. So what you're going to do is you're going to take 3x minus 4y is 24. You're going to substitute in y to be 0 to find the x-intercept. You get 3x minus 4 times 0 is 24. And what you end up with is 3x is equal to 24, and you're going to get x is equal to 8. X is equal to 8. All right? And then what you're going to do is you're going to plot the y-intercept. You're going to plot the y-intercept. Let's do that right here. So to plot the y-intercept, you're going to make x equal to 0. We don't have time to talk about y because they only give me half an hour. So what you're going to do is take the 3x minus 4y is equal to 24, and you're going to substitute x to be 0. So you get 3 times 0 minus 4y is 24. You get negative 4y is 24. You're going to get y is negative 6. That's your y-intercept. So what you'd end up doing is you take the x-intercept, which is the point 8, 0, And actually, I'm sorry, it's cut off. This is a 0.6, and then it'd be a 0.7, and it'd be a 0.8. So you'd plot a point. I'm sorry, I didn't make the coordinate axis large enough, but you go 6, 7, 8, and you plot a point right there. I'm not going to write on the table, but you plot a point right there. And then you go to the y-intercept, which is a point 0, -6. 0, -6 is this point right here. So you plot a point here, you plot a point over here, you draw the line, and I want you to be able to see you're actually drawing the same line. You would be sketching the same line in more than one way. We call that mastery level understanding of a problem. And then there are things like you can put in the calculator. You can put this in a calculator. The calculator will draw it for you, and you'd end up with the same line. There are a lot of ways to get the same sketch, mastery level understanding. And this is what we're encouraging our students. We're encouraging our students to dominate problems because they can do it.